For the first time in history, Mars, not Earth, has captured an interstellar visitor. But as the red planet sends back faint images of Three-Eye Atlas, something strange is happening. Every major Earth-based telescope has gone silent. No updates, no public data, just silence. Why is NASA keeping quiet? And what exactly did Mars see? For months, the telescopes of Earth had tracked a faint visitor cutting across the void, an interstellar object labelled Three-Eye Atlas. It wasn't bright, but it was historic. Only the third confirmed wanderer from beyond our solar system. Astronomers followed its path with a kind of nervous devotion, watching each pixel of light drift across their CCD sensors. Then, without warning, the feed began to fade. By early October, the object slipped too close to the Sun for comfort. Telescopes that had watched it faithfully, Hubble, Webb, and dozens of ground-based observatories, saw the sky fill with glare. The signal flattened into background noise. Every data stream that had once plotted its coordinates went silent. Official channels called it superior conjunction, a harmless term for the weeks when a target hides behind the Sun. But for researchers who had grown used to daily updates, it felt more like a blackout. In control rooms from Hawaii to Chile, operators closed domes and powered down detectors. Screens that had shown streaks of interstellar dust now displayed static. Nothing to measure, nothing to confirm. We were blind. And the silence that followed was louder than any discovery. Three-Eye Atlas was still out there, moving, rotating, changing perhaps. But from Earth, no instrument could see it. The same sun that gives us life has become an optical wall between us and the unknown. It's a cruel symmetry. The light that sustains our species can also erase our vision of everything beyond it. Within hours, speculation filled the vacuum. Forums buzzed, feeds multiplied rumours, and the familiar cycle began. Mystery breeding conspiracy. Some said NASA was withholding images. Others claimed private telescopes had been ordered to shut down. None of it is confirmed. All of it is plausible enough to keep audiences scrolling. The simple truth was less cinematic but more unnerving. We just didn't know what was happening anymore. For the next 6 weeks, the object would remain hidden on the far side of the Sun, unreachable to every major instrument on Earth. In that interval, no new light curves, no updated spectra, no orbital corrections, just numbers frozen in time and a growing sense that the universe had pressed pause. Every era of science meets a moment like this, a pause between signals when curiosity outpaces visibility. The danger isn't the darkness itself, it's how quickly we fill it with noise. For centuries, humans have built lenses to fight ignorance, yet here, in the 21st century, with observatories circling the planet and telescopes parked 1 million miles from home, a single alignment of orbits can still blind an entire civilization. And then comes the twist. While Earth stared into the Sun, another world was looking up. Hundreds of millions of kilometers away, on the dusty plains of Jezero Crater, a robotic rover pointed its camera toward the same sky we could no longer see. The Perseverance rover, built to study rocks, had become our last functioning eye in the cosmos. What it captured next would reignite the mystery, spark debate across agencies, and raise a question no one expected to ask. Why did Mars see what Earth could not? And why hasn't NASA told us everything it found? While Earth turned blind in the glare of the Sun, Mars quietly kept watching. No observatories, no multi-billion-dollar telescopes, just a single rover sitting on rust-red dust, still awake, still working. Perseverance was never designed to study the deep sky. Its mission was simple: drill into Martian rock, hunt for ancient microbes, and send the findings home. Yet on the nights of October 3rd and 4th, it looked up instead of down, and captured something no other camera in the solar system could. From its station in Jezero Crater, the rover's Mastcam-Z and Navcam performed long-exposure photography of the Martian night. Each frame, a 29-second exposure, was meant to test sensor performance and track star positions for calibration. But this time, those faint, grainy images contained more than calibration stars. In the background of that alien sky hid a visitor, the elusive interstellar object known as Three-Eye Atlas. It wasn't NASA who discovered this. It wasn't ESA or China or the UAE. It was 2 civilian astronomers, ordinary people with extraordinary patience, who pulled the data from Perseverance's public feed and decided to look deeper. Their names surfaced later in scattered astronomy forums. Simon Schmov and the user known as Astronomy Live. They weren't backed by institutions, they weren't paid by any space agency, and yet they became the first humans to glimpse 3i Atlas from another planet. They began by downloading hundreds of raw Perseverance frames, each littered with noise, dead pixels, cosmic rays, and dust artifacts. One by one they stacked them, aligned them against known star patterns and subtracted dark frames to remove camera interference. The process was slow, delicate, and unforgiving. Most people would have seen only static, but through meticulous stacking and averaging, the faintest cloud of light began to emerge, a pale smudge slightly greener than the surrounding sky. That was it. That was 3i Atlas. The image wasn't dramatic. It wasn't a glowing cylinder or a crisp spacecraft silhouette. It was subtle, a whisper of movement in the dark, but in science, subtlety is everything. That faint signature proved that the interstellar traveller was still on its predicted path, visible from Mars exactly where orbital mechanics said it should be. It was still there, doing whatever it was doing, spinning, outgassing, or maybe just coasting silently past the sun. Back on Earth, no official channels mentioned this. No press releases, no data briefs, no congratulatory tweets from NASA's public accounts. The discovery didn't come from official sensors, it came from enthusiasts working through a dusty server of unfiltered images. In an age of instant headlines, this kind of discovery felt old-fashioned, a reminder that sometimes progress doesn't arrive through institutions, it sneaks in through passion and persistence. Imagine that. Two amateurs, working from laptops, uncovering evidence of an interstellar object millions of kilometers away, using pictures taken by a robot they didn't even control. In a cosmic game of hide and seek, they were the ones who found what the professionals had missed. Their find confirmed two things. First, that Mars, against all odds, had become humanity's only functioning observatory capable of tracking 3i Atlas. And second, that transparency in space exploration, open data, public archives, and citizen science wasn't a luxury, it was a lifeline. For a brief moment, the flow of information had reversed. The public, not NASA, was informing the world about the cosmos, and that inversion made people uneasy. If two civilians could do this with raw rover data, what else could be hidden inside the images we never get to see? As the processed pictures spread online, forums lit up with new energy. Some saw proof of diligence, others smelled secrecy. Yet the facts were simple. The object was there, faint but real, seen from Mars while Earth remained blind. Humanity's last open eye had given us a glimpse through the fog. But with that glimpse came a new question, one far bigger than any photograph could answer. If a rover on another planet can show us what's really happening out there, what exactly is NASA not showing us here? The discovery from Mars should have triggered celebration, confirmation, analysis, press briefings, public excitement. But none of that happened. Days passed. NASA, ESA, the Chinese National Space Agency, and the UAE's Hope mission, all silent. No new images, no official statements, just a void of communication large enough for speculation to grow roots. What made the silence so strange was that everyone knew the data existed. Multiple orbiters around Mars, NASA's Mars Reconnaissance Orbiter with its high-rise camera, ESA's Mars Express and others, had pledged to capture 3i Atlas during its close pass. These are instruments capable of photographing features the size of a coffee table from orbit. Yet, when the moment came, nothing surfaced. Officially, the reason was data backlog. The agencies were prioritizing ongoing mission uploads, processing schedules, and calibration cycles. Unofficially, people wondered, how could a pair of civilians process raw rover images in 2 days, while billion-dollar missions hadn't produced a single public frame after weeks? The math didn't add up. Some blamed bureaucracy, others pointed to timing. The US government had just entered a partial shutdown, a familiar political ritual that freezes funding across federal agencies. That meant NASA's public communication offices were closed, staff furloughed, and non-essential data releases paused. But paused didn't explain the international silence. ESA wasn't shut down. The Chinese and Emirati missions weren't either, and still, the data stayed locked. Inside research circles, the term data quarantine began to appear, an unofficial waiting period used when anomalies require internal review. Agencies don't like surprises. When an observation contains unexpected shapes, brightness, or motion, analysts double-check everything before releasing it to the public. It's a reasonable protocol, but also an easy excuse. Every hour of delay feeds curiosity and mistrust. In the vacuum, theories multiplied. Some whispered that NASA had indeed captured higher-resolution images but withheld them until confirmation of what the object actually was. Others suggested the agencies were coordinating a joint release to avoid conflicting interpretations. And then, inevitably, came the third theory, the one that always emerges when institutions go quiet. Maybe they found something they didn't want us to see. That phrase, "didn't want us to see," is powerful because it appeals to two instincts at once: fear of deception and hunger for hidden truth. Both keep audiences hooked, and yet, the deeper truth might be less cinematic and more human. The space industry runs on caution. One misinterpreted pixel can set off international headlines. One error in calibration can spiral into a year-long conspiracy. The safest move is often silence. Still, silence feels like betrayal to the people paying attention, because Perseverance's public feed proved one thing: data transparency works. When information is open, discovery accelerates. When it's hidden, rumour fills the gap. If NASA had immediately released even a blurred thumbnail of what its orbiters captured, the story might have stayed grounded in science. Instead, the secrecy made room for the supernatural. It's easy to forget how fragile trust is in the age of instant access. The internet trained us to expect live streams from Mars, not embargoes. When a government agency goes dark, the default assumption isn't protocol, it's cover-up. But here's the reality. Not every locked dataset hides a scandal. Some simply hide uncertainty. Raw images are messy. Exposure streaks, dust shadows, cosmic rays, all can mimic motion. Analysts have to clean them, cross-check coordinates, and ensure that what looks like a comet isn't just a dead pixel amplified by hope. That takes time, and time, unfortunately, looks like secrecy when the world is waiting. Still, perception matters. For the public, every day without data widened the gap between curiosity and trust, and into that gap, louder voices stepped. People who didn't care about calibration or context, they cared about headlines, the kind that say, NASA hides proof of alien craft. It was no longer a question of what Mars saw, it was about why Earth refused to speak. And in that silence, misinformation began to roar. Information doesn't die in silence, it mutates. As days turned into weeks without official word from NASA or ESA, the internet filled the void with noise. On Reddit threads, Telegram groups, and YouTube channels, new evidence surfaced every few hours. Screenshots, cropped photos, colour-enhanced images labelled leaked from Mars feed. The most viral among them showed a long, bright streak hovering above a dim Martian horizon. To some, it was obvious. A cylindrical craft, reflective, metallic, and undeniably artificial. Except it wasn't. The object in question turned out to be Phobos, one of Mars's two small moons, lumpy, irregular, and tidally locked. During Perseverance's long exposure shots, Phobos's motion and the planet's rotation created a stretched smear of light across the frame, a simple optical artifact. Yet within hours, the image had been shared thousands of times with captions like, "NASA slip-up, alien cylinder caught over Mars." Then came the Medium post by Avi Loeb, the Harvard astrophysicist known for championing the possibility of interstellar technology. His article speculated on the cylindrical stripe captured by Perseverance's navcam, suggesting it could represent 3i Atlas itself. He never said it was proof, but few readers made it past the headline. Within a day, blogs and influencers had stripped the question marks from his text. Harvard professor confirms interstellar ships spread like wildfire. This is how rumour evolves. A photo becomes a theory becomes a statement, and a statement becomes fact through repetition. The algorithm rewards confidence, not caution. The louder a claim, the faster it travels. And in a world hungry for disclosure, alien always outruns artifact. Behind the scenes, genuine experts tried to correct the record. planetary scientists released comparison frames showing Phobos's orbit and rotation rate. Amateur astronomers recreated the exposure effect with their own simulations. But facts move slowly when emotion is faster. Fear and excitement share the same neurological pathways. They both make the heart race, and they both keep people watching. This was the paradox unfolding in real time. The most rational explanation was also the least shareable. Saying it's Phobos doesn't spark adrenaline. Saying they're hiding something does. The truth was losing on engagement metrics, and yet the misinformation served a strange purpose. It reminded the public that trust is earned, not owed. When institutions leave a vacuum, audiences fill it with whatever feels meaningful. The Phobos incident wasn't proof of deception. It was proof of hunger, for wonder, for answers, for belonging to a story bigger than everyday life. People wanted to participate in discovery, not wait for sanitized press releases. The narrator's voice, Stephen Burns, the geophysicist who broke the original update, became an anchor in that chaos. He didn't mock believers or dismiss questions. Instead, he did what scientists rarely do in public. He explained uncertainty. He showed how image processing works, why brightness matters, and why slow movement can't equal proximity. Each clarification pulled a few viewers back from the edge, and for every viral clip shouting "alien ship confirmed," there was a quieter one saying, "Look again, here's what the data actually means." That's how credibility survives the storm, not through authority alone, but through patience. The lesson was obvious to anyone paying attention. In the digital age, transparency isn't optional. It's the only defense against chaos. Silence breeds stories, uncertainty breeds myths, and both can spread faster than the truth if left unchecked. By the time NASA finally hinted that processed imagery from its orbiters would be reviewed and released in due course, the narrative had already split into two realities, one scientific, one sensational, and in between them stood the same haunting question that had lingered since the first Perseverance images surfaced. If there's nothing to hide, why does it feel like someone's hiding it? Silence is not always a conspiracy. Sometimes it's just a symptom of a larger design flaw, an entire civilization built to look inward instead of outward. But when that silence comes from the world's most powerful space agency, at the exact moment an interstellar object slips out of view, it starts to sound less like a coincidence and more like a confession. NASA has always lived in the paradox of transparency. It's a government agency funded by taxpayers, yet its data pipelines are tangled in red tape, policy, and the slow machinery of bureaucracy. When something unusual appears in the sky, the reflex isn't to share, it's to verify, and that process can take weeks, even months. But perception moves faster than paperwork. To the public, pending review looks like cover-up. During the first week after 3i Atlas vanished behind the sun, staff inside NASA's Jet Propulsion Laboratory were operating with skeleton crews. The US government shutdown had furloughed thousands of employees, including public affairs officers who handle mission updates. Mars Reconnaissance Orbiter, Mars Express, and other probes still collected data, but their downlinks were frozen in bureaucratic limbo. No one was authorized to publish. No one wanted to risk an error that could ignite controversy. Meanwhile, other agencies, ESA, CNSA, the UAE Space Agency, stayed just as quiet. They weren't hampered by Washington politics, yet they hesitated for the same reason: coordination. International missions often agree to release synchronized findings to avoid conflicting reports. But when one player goes silent, the others follow and the entire network stalls. In that pause, rumor metastasizes. If you zoom out, this isn't just NASA's issue, it's a planetary one. Humanity's entire space-watching infrastructure is still centralized around a single point: Earth. Every major telescope, every data hub, every mission command sits beneath the same sun that blinds us during superior conjunctions. One celestial alignment, and our instruments go mute. We built our eyes in one place, then act surprised when they all blink at once. This is the systemic blind spot, not a political metaphor but a literal architectural flaw in how we observe the universe. We have orbiters around Mars, probes in deep space, telescopes at Lagrange points, but the command, funding and data authority all flow back through Earth. When Earth loses sight, the system collapses into silence. Imagine if weather forecasting on Earth depended on a single radar station. That's how we treat cosmic surveillance. We call ourselves a spacefaring species, but we still watch the sky like villagers staring through one window. The interstellar object 3 Atlas exposed that weakness perfectly. As soon as it crossed behind the Sun, every Earth-based asset went blind. Mars had the only vantage point, but Mars doesn't publish press releases. Its cameras record, its antennas transmit, but the decisions about what to share are made here, on a planet now shielded by sunlight and bureaucracy alike. Inside private astronomy circles, this sparked a bigger conversation. Why haven't we built independent observatories scattered through the inner solar system? Why no Hubble-class telescope in Mars orbit, or at Venus's trailing Lagrange point, or in polar solar orbit? The technology exists. The funding somehow does not. Part of the answer lies in risk management. Agencies allocate budgets where political reward is visible. A mission that studies Martian dust wins headlines. A telescope parked halfway to Mercury does not. Preparedness rarely earns applause until the day it's missing. And so, here we are, an entire species temporarily blind to a visitor from another star, debating on forums instead of observing through glass. Stephen Burns put it bluntly in his broadcast, "We're like children playing in a sandbox without a flashlight." The metaphor stung because it was true. For all our satellites and sensors, our awareness of the cosmos is fragile, a few degrees of solar glare away from ignorance. The real danger isn't what NASA might be hiding, it's what no one is watching. If an interstellar object entered our system on a collision course tomorrow, the odds are high we'd miss its critical weeks of approach simply because the Sun happened to stand in the way. We'd be forced again to rely on luck, or on a rover's camera pointed at the sky by chance. That's not a conspiracy. That's negligence born of complacency. Silence from NASA isn't proof of secrecy. It's proof of unpreparedness. We built the most advanced machines in history to explore other worlds, yet we still haven't learned the oldest lesson of exploration. Always keep a second lookout. The question isn't whether 3i Atlas is alien. The question is whether we're ready for a universe that keeps surprising us, and whether our systems are built to respond when it does. Because right now, one bright star is all it takes to make an entire planet deaf. When the light of a single star can blind an entire civilization, the question isn't about astronomy anymore, it's about maturity. Humanity has reached the point where our curiosity outpaces our coordination. We can launch nuclear-powered rovers across millions of kilometers, yet we still depend on one planet's line of sight to know what's coming toward us. For a species that dreams of colonizing other worlds, that's a sobering contradiction. Moments like this, when 3i Atlas slips into the sun's glare and the sky turns quiet, force us to look inward. They remind us that preparedness isn't just about hardware or budgets, it's about mindset. The truth is, we haven't learned to think cosmically. We still think nationally, bureaucratically, politically. Space exploration runs on contracts, committees, and election cycles, not continuity. And so, every time something unpredictable happens out there, we act surprised. But the universe doesn't care about our paperwork. It moves on its own schedule, indifferent to the boundaries we draw or the funding we debate. 3i Atlas is a messenger from that indifference, a silent reminder that the cosmos doesn't pause for our bureaucracy. It keeps going, with or without us. Preparedness, in its simplest form, means anticipation. It's the ability to ask what if, before we're forced to. What if this object had entered on a trajectory closer to Earth? What if it had fragmented near the Sun and sent debris our way? What if one of those fragments carried something we didn't expect? Organic compounds, metallic alloys, a design that didn't belong to nature? These questions aren't paranoid, they're necessary, because every discovery begins as a what if, and ignoring them doesn't make the universe safer, it only makes us slower to respond. For centuries, humanity's story has been reactive. A meteor wipes out a forest, and we study it afterward. A solar flare knocks out satellites, and we upgrade the shields later. An interstellar object passes through our system, and we notice it only when it's leaving. We keep treating space like a stage instead of an environment, a backdrop for discovery, not a field of responsibility. But that's changing, slowly, unevenly. The Perseverance images, those faint noisy frames, represent more than a glimpse of Three-Eye Atlas. They represent the beginning of a new awareness, that we're no longer just observers of the cosmos, but participants in it. Mars didn't plan to be our observatory, but it became one. That's evolution in real time. One planet's limitation turned into another planet's advantage. It's a glimpse of how the future of space science could look: distributed, resilient, interconnected. To be prepared means building systems that outlive politics and survive blind spots. It means decentralizing our vision, creating independent observatories across multiple worlds and Lagrange points, so that no single alignment of the sun can silence us again. It means empowering citizen scientists, the same way Simon Schmov and Astronomy Live processed Mars data before any agency did. Preparedness isn't paranoia, it's respect for the scale of the universe and the smallness of ourselves. And maybe that's the hardest truth of all. We love to imagine ourselves as the clever species, the problem solvers, the builders, the watchers of the stars. But cleverness without humility becomes arrogance, and arrogance, in the language of the cosmos, translates to extinction. If Three-Eye Atlas turns out to be nothing more than a fragment of ice and dust drifting between suns, it still carries meaning. It reminds us that visitors from the void don't announce themselves. They appear, cross paths with our fragile awareness, and disappear again. We get one chance to look, and if we're not ready, we lose it. Being ready isn't about expecting aliens. It's about expecting anything. It's about realizing that preparedness and curiosity are the same instinct, pointed in different directions. The Scouts' motto, "Be prepared," isn't just a slogan for survivalists. It's the foundation of science. Anticipate, observe, adapt. We've built rovers that can think, telescopes that can see galaxies form, and probes that have left the heliosphere. But none of that matters if we can't see what's right behind the sun. Until we fix that, we're explorers with one eye closed, so the next time an object like Three-Eye Atlas visits, and there will be a next time, we'll have to decide what kind of species we want to be. One that waits for institutions to tell us what's safe to know, or one that builds the tools to know for ourselves. One that hides behind bureaucracy, or one that looks through it. Because readiness isn't just about defense, it's about dignity. The dignity of awareness, the dignity of curiosity, the dignity of saying, we may be small, but we're paying attention. When the universe tests us again, and it won't be asking if we believe in aliens. It will be asking if we've finally learned how to keep our eyes open. Soon the sun will move on, the glare that blinded our telescopes will fade, and Three-Eye Atlas will drift back into view. December will bring a window, a few brief weeks when the object emerges from the solar haze, and our instruments once again can see. By then we'll know whether our calculations were right, whether it stayed on course or changed direction, whether it's a comet, a rock, or something we've never seen before. Until that moment, we wait. But waiting doesn't mean doing nothing. Teams across observatories are preparing their arrays, calibrating sensors and scheduling telescope time. Amateurs are writing scripts to scan public feeds the second they reopen. Even now, the SOHO and stereo coronagraphs might catch a glimpse of Three-Eye Atlas skimming the sun's outer light if it's bright enough to reveal itself. Every frame, every pixel matters, and yet the bigger lesson isn't about the data, it's about perspective. We've learned that blindness is part of discovery. Every silence teaches us how much we still rely on light, on communication, on cooperation. We've learned that citizen scientists matter as much as billion-dollar missions, and that truth moves faster when everyone can see it. When the first new images arrive, they'll tell us more than what Three-Eye Atlas looks like. They'll tell us what kind of watchers we've become, whether we learned from this blackout, whether we're building a smarter system, whether curiosity still outweighs complacency. Until then, we stay curious, we stay alert, we keep looking up, knowing that even when the sky goes silent, the story doesn't end, it just moves beyond the light for a while. Because the universe doesn't hide its secrets forever, it simply waits to see who's patient enough to look again. So as we wait for the first clear images of Three-Eye Atlas to re-emerge from the sun's glare, one truth remains. Curiosity is our strongest telescope. The answers may come tomorrow, next month, or never, but what defines us is that we keep searching. Because the sky doesn't belong to any agency or government, it belongs to those who dare to keep looking when the rest of the world turns away. If this story made you think differently about how fragile our cosmic awareness really is, then stay with us. Subscribe to the channel, turn on notifications, and share this video with someone who still believes exploration should be transparent, not classified. Your curiosity keeps these investigations alive. Until the next signal appears from the dark, keep your eyes open, stay curious, and remember, every silence in space is just the universe inviting us to listen closer.